My dear students, class 10 Cbse. Hope you are in a good state of mind and cheer. I welcome you all to our channel Mind Mapping. And your exam is approaching, is knocking at the door. And in the meantime, Cbse has released sample question papers in different subjects. And you might have gone through the science sample question papers and the marking schemes developed by the Cbse. I appeal you, I advise you all to please carefully follow the sample question papers, not for this year, not for the coming means of the forthcoming examination, but for the previous 3 years. And out of that sample question, we have detected one question that's from physics electricity. That's a numerical problem. One student, one of your friend from JNB raised this question and he solved in two different ways, but the answer is vice versa. So I present you, and it has been explained in your marking scheme prepared and provided by the Cbse. So let's solve the problem. Let's read the problem first. The given figure, you see the given figure, shows two resistors. You see resistor R1 and R2, two resistors connected in series to a battery. You see the battery, and we have taken two batteries, but in the sample question paper, three batteries have been taken. Okay, that doesn't matter. The series to a battery, the power dissipated for this connection is P1. This is very important. P1. And when these resistors, means R1 and R2, two resistors X and Y, are connected in parallel, that we have shown here. This is not given in your answer sheet, but actually for your better understanding, we have displayed here two connections. One is series connection and another is parallel connection. When these resistors are connected in parallel, the second figure, to the same battery, you see the same battery, then the power dissipated is given by P2. You see P2 and here P1. Okay. And what we have to do, what we have to find out? We have to find out the ratio of power consumed in the first case and the power consumed in the second case. The ratio of P1 and P2 is to be derived. So we have to find out the ratio of P1 and P2. Now come to the solution. So this solution, this solution has been described in your marking scheme. So let me explain for your better understanding. So P1, you know power. Power P is equal to V into I, voltage into current. That is the formula you have to remember. And another thing, you see, if we convert from Ohm's law, if we apply Ohm's law, I is equal to V by R, then the formula is V square by R. The first formula. And the student X, he applied this formula to find out the ratio in this case. So V square by R, applying Ohm's law, V into I. So I, you know, V by R. Okay. So this is substituting V by R. So V square by R, this formula has been derived and it is given in your textbook. Okay. Now you see, so R, we have to find out R. So V square, the V is fixed for two cases. Means voltage is fixed for two situations, two connections. In the first case, the resistors are connected in series. So what is the total resistance, or what we call what is the equivalent resistance? So this is R1 plus R2. So R plus 2R is equal to 3R. So this is the total resistance in the first figure, the first connection. Okay. So applying this formula P1, the power consumed. Okay. So V square by R. So V square by R, R is 3R. So we got this. We got P1. Okay. The first case, the power dissipated, the power consumed actually B square by 3R we derived. So let's come to the second case. In the second case, you see the two resistors are connected in parallel. In parallel connection, this formula is used 1 by Rp. Rp means resistors are connected in parallel. 1 by Rp is equal to 1 by R plus 1 by 2R. So the result is 2R, 2 plus 1, 3, that is 3 by 2R. But here you commit a mistake. 1 by Rp is equal to 3 by 2R. So what is Rp? That is 2R by 3. So here total resistance is 2R by 3. Now putting the value of R in the formula V square by R, V square by 2R by 3. Now the result is 3V square by 2R, because V square by 1 and the denominator will be numerator. Okay, 3V square by 2R. So this is P2. Now the student X, he got P1 and P2. Now it is very easy, very simple to calculate the ratio. Okay, so P1 by P2, so V square by 3R. So V square by 3R, you see, V square by 3R here, P1, and what is P2? 3V square. Here you see 3V square by 2R. Now you see V square by 3R into 2R by 3 V square. Now you see V square cancel and RR cancel. So 2, 3 into 6, 2 by 9. So ratio is 2 by 9. Mean the student X, he got this answer. But actually in same class, another student Y, he solved the same problem in this way. Okay. So there was a conflict between two students. But it has been given in the marking scheme prepared and displayed by the Cbse. So the student Y argued. Okay. So P is equal to V into I. So P is equal to Vi. That formula here he applied. And instead of actually changing V, okay, so he changed V. So V is equal to IR according to Ohm's law. So IR into I square R. So P is equal to I square R. So P is equal to I square R and P is also equal to V square by R. There are two formulae. Okay. And the student Y applied this formula. Now you see. So P1 is equal to I square into 3R. 3R means this is the total resistance of the first connection, you see 3R. So he got actually 3I square R. 3I square R. So that is the P1 the student Y got. Okay. Then for second calculation, the two resistors connected in parallel for P2, he calculated P2 is equal to I square R, same formula. Then I square and total resistance that has been derived, total resistance here you see 2R by 3, 2R by 3. Okay. Here the total resistance of two resistors connected in parallel. So now this is 2I square R by 3, that is P2. He got P2 here. Now it is very simple to calculate the ratio P1 by P2. Now in the first case you see, the first P1 is equal to 3I square R divided by 2I square R by 3. Okay. So this is means some circumference, this is by 1. Okay. So 3I square R into 3 divided by 2I square R. Now I square cancel, R cancel. Now the ratio is 9 by 2. He got 9 by 2. And he argued, why I am not correct? Why we say you are wrong? This is wrong and this is right. The teacher told, no, it has been prescribed, it has been given in the sample question paper. But the argument of the student is I applied this formula and he applied that formula. And the result is actually just changing, just vice versa. Okay. The ratio is just vice versa. So where is the wrong? So the teacher has to explain. No, of course, in that case, the teacher failed to answer. Anyway, this question is meant for my students and their guide teachers to give answer. The why is wrong, why, and what are the probable reasons for which this answer is wrong. So we have to justify. Otherwise, you can say it is wrong. So please write to justification or two reasons. Okay, and please write your answer in our comment box. This is a comparative problem. This is a comparative solution, not problem, comparative solution. But this is accepted and this is rejected. Why? The question is why. Okay, and here this is called the comparison, higher level of understanding, the comparing the two situations and using two formula and why it is accepted, why it is not accepted. So you have to clarify and you please write your answer in your comment box for, for clarifications. Thank you for watching, and if you like, and we have taken our endeavor, we have started this endeavor to present or to analyze, to discuss your sample question papers. From each questions, we shall develop number of questions that have been said previously, and that are likely to be said. So we shall discuss one by one. We have started this series right from today. Please stay tuned, and if you like, you may subscribe to our channel to watch our series of videos. And at the last but the least, I would like to appeal to my OTT teachers and prospective students, those who have appeared and intend to appear. Please stay tuned to watch a video that is to be uploaded shortly in the evening. Thank you for watching. Again, thank you all.